Okay, in this section or in the next 3 sections, we are going to be graphing these sine and cosine function. I know we haven't really talked about that very much. We kind of only talked about degrees, radians, and then the unit circle. But the whole idea of doing any of the unit circle is to figure out the sine and cosine functions of those angles. And so what we want to do is actually look at the graphs of these functions. So today we are going to look at the sine function. So what I want you to do is go ahead and graph the sine function in decimals. So you want to type in y equals sine x. And what I want you to do is estimate the values of y using decimals. So I'm going to show you how to do that. Okay, so sorry, this is very hard to show you because I cannot run a live decimals, but this is how it's going to look like. So once you type in sine x, it's going to show you the graph, and you can see that it's a kind of like a squiggly graph. And then what you're going to do is look here. This says sine 2 is y. So what we want to do is when x is 2, what is y? Meaning if I put 2 in as x, what is the y value, or how high is this going to be? So what you want to do is look over here on your graph. This is the sine x graph. So what you want to do is look at 2. So this is 2. And then you kind of approximate what is y here. Y looks like it's a little bit lower than 1. So I would say maybe 0.9. You can also, because this is not a live decimals, you can also put your finger on the graph and it will actually tell you what that value is. But it's about 0.9. And then what I want you to do is go ahead and do the same thing for sine pi, sine 30 degrees, and then sine 3 pi over 2. Now, you might be wondering how you're going to figure out where pi is, or 30 degrees and all that stuff. So what you do is, if you want to have this in radian, so you see how this is already in radian, it's already checked, I guess it's highlighted. But it doesn't show pi, it shows 1, 2, 3 radian. So if you want it to show pi, you have to type in pi over here on the step. For the x-axis step, you want to type in pi. And what you do is you go to the keyboard function and you type in pi. There's a pi key on there. Okay, and then same thing, if you wanted to show up as degrees, you would click on this one and then everything is going to turn into degrees. Okay, so hopefully that's enough instruction for you to know how to change between radian, degrees, and then show actual pi on the step part. Okay, so go ahead and do the other 3, and then pause the video, pause the video, do the other 3, and then come back and check your answer. Okay, so hopefully you got the correct answer. Now, of course, the other way to do this is just look at your unit circle. It will give you the exact same numbers. All right, so at this point, I want you to actually copy and paste y equals sine x, and then paste it in here. So I am going to try to move that graph, or just add another graph. All right, so what we're going to do is first we're going to examine the graph. First, let's look at some vocab. Amplitude. Amplitude means the height of the graph, but not the total height, the height from the center of the graph, so from the middle of the graph. So what you're going to do is you are going to take the total height, let me write this down. Total height divided by 2. Okay, total height divided by 2. And or you can just see that it's if you have an equation, it's the leading coefficient, but the absolute value of the leading coefficient. So let's answer this question. What is the amplitude of the graph? All right, let's look at this graph. The amplitude is the total height divided by 2. So what is the total height? You can see that it goes up 1, down 1. So the total height is 2. Divide by 2 means the amplitude is 1. The other way to look at it is, like I mentioned, it's from the center of the graph to the top or the bottom. So basically, how high is this? It is 1. So amplitude is 1. And amplitude, because it's a height, it's always a absolute value, meaning it's just going to be a length. And length, we never talk about negative. So you're not negative 5 feet tall. You're not going negative 10 feet away. So it's always positive. All right, so in this case, the amplitude is 1. Okay, next, period. Period means cycle, or the length it takes for this curve to complete a cycle. Well, what is a cycle? So it is how long it takes this graph to repeat itself. So you can see that this graph is obviously going to have a pattern, right? So it looks like it's going up and down, up and down, up and down. So there is a pattern to this. The question is, how long does it take for this graph to repeat the same pattern again? Well, what you want to do is so for me, sometimes it's hard to see a pattern. So what I do is I take the top to the top, and then I ask myself, what is this length? Or I take the bottom to the bottom, and I ask myself, what is this length? It should be the same. That's how long it takes. So basically this part, if I repeat it, it will be the same pattern again. So from the top to top, that is how long it took for it to repeat itself. So let's take a look. It looks like it started from negative 3 pi over 2, ended on pi over 2. So the question is, how long is that? Okay, so if you're not really good at calculating with negatives, so you can think of it like this. From here to here is 3 pi over 2. Forget about the negative because we're talking about length. So this part is 3 pi over 2 plus this pi over 2. So 3 pi over 2 plus pi over 2 is going to give us 4 pi over 2, which is 2 pi. So this tells us that the length which it takes to repeat itself is 2 pi, or the period is 2 pi. So what is the period? That is 2 pi. Okay, now you may not always have a graph. So what you want to do is actually look at the equation and be able to tell what is the period. And here is the formula. The period formula is 2 pi divided by absolute value b. And notice that b is the number that is multiplied next to x. Okay, it's next to x. Next part, number of cycles. Number of cycles is just asking you know, within this certain amount of length, how many times does the graph repeat itself from, let's say, 0 to pi? And if it's from 0 to pi, then the number is just b. Now let's look at the last thing. What is the domain range and range of this graph? So what is all the possible x's and what is all the possible y's of this graph? Let's say that this graph goes on forever. So what is all the possible x values? So you ask yourself, is there any point where x does not exist? Where can I keep going to the right? Can I keep going to the left? And are there graphs that exist on those? Yes. There is graph that exists on all the x values, so the domain is all real numbers. Now let's ask ourselves, what are all the possible y values? Well, if you take a look at this graph, it looks like it's just going to go up and down between -1 and 1. So that means the range is just between -1 and 1. All right, so what we're going to do now is So what we're going to do now is we are going to be given a graph. We are going to rewrite an equation. So what you want to do is be able to tell what kind of graph this is. A sine graph will always start at 0, 0, 0, and then it's always going to go up first and then down. Okay, this is the normal sine graph. So normal sine graph. If it differs from this, then it may be something that is not sine, or it's very similar to sine. We just need to change something. We don't know, but this shape is a normal sine graph. So it has to go start at 0, and then it has to go up and then down. All right, so this looks like a sine graph. What we want to do is be able to write an equation. To write an equation, we need A and B. All right, A has to do with the amplitude, meaning from the center, how high or how low does it go. You can see that this one is going to go to 2, so A is 2, because the center is 0. Okay, if the center is not 0, then it's something else. B has to do with period, meaning how long does this take for it to repeat itself. So like I mentioned before, what you want to do is look at the top versus the top. And then you ask yourself, how long was this? Well, this one of the top is at pi. The other one is at 5 pi. So then the distance has to be 4 pi. Okay, so B is not 4 pi. The period is 4 pi. Now you need to recall the period formula. Period formula is 2 pi over absolute value B, or let's just put B. Okay, so what we want to do is back calculate B. If you're not sure how to do this, please make sure you put it over 1 and you want to cross multiply. Okay, so this is 2 pi equals 4 pi B. So then B is 1/2. B is 1/2. And I went ahead of myself. Period is 4 pi. So at this time, we can write the equation. The last thing you want to do is just double check. Is this sine graph going in the right direction? Does it go up and then down? Or sometimes it will go down and then up. If it goes down and then up, that means there is a reflection. But there isn't. So this equation is y equals 2 sine 1/2 x. Oh, I should probably write it here instead. All right, so let's have you practice. A and B, it's already given to you, the amplitude and the period, but C, you do have to look at it and figure out the answer. So pause this video, try it, and then come back and check your answer. Okay, so hopefully you got to check your answer, or you finished it and then now you can check your answer. So on the first one, it's a pretty simple one. Amplitude is 3. The period is 3 pi over 2. So what you want to do is back calculate B. In this case, B is 4/3, so you get this equation. Part B is also very simple. Amplitude is 1/2, period is 3 pi. Again, you want to calculate B. B is 2/3, so then this is the equation. The third one is a little bit trickier. So what you want to do is look at the height, the maximum to the maximum. That tells you how long the period is going to be. And since this one here on the left, that is in the middle between 0 and negative pi over 2, that point has to be negative pi over 4. And same thing on the other side. So this whole period is pi. So when you back calculate, B is 2. So A is 2, B is 2. Now the tricky thing on this one is if you look at this graph, the graph goes down first. Down first means that there is a reflection going on. It is not exactly the same as the original one. It flips down first, and the only way you can have it flip down is you put a negative on it. So this is going to be your final answer. Okay, now we are going to practice graphing. So graphing this is a little bit tricky, but there's some steps you can follow. First, you want to find A, B, and then find the period. Okay, so let's go ahead and look at this one. Graph one cycle of y equals 1/2 sine 2 theta. So A is 1/2, B is 2, and then period, you want to recall that formula. So that is 2 pi over B. So 2 pi over 2, which is pi. All right, at least get those things identified. That's step one. Step two, we're going to draw a axis. So first, let's draw this. Okay, xy, and we are going to label this. We're going to draw one period and then divide the axis into fourths. Okay, so we are going to draw where one period should be and then divide this axis into fourths. Okay, so let's look at it. So this is a normal sine graph, so this tells us that our period is what, pi. So we're going to draw pi here. That is one period. What we're going to do is we're going to divide this into fourths. Fourths means the fastest way to divide things into fourths is you cut it in the middle. So that is going to be pi over 2. And then from the middle, you're going to divide each half by half again. So that means take this half, divide it into half. So that's going to be pi over 4. Take this half, divide it into half. That is 3 pi over 4. Okay, so divide it into 4 equal quarters. And then what you want to do is label your amplitude. So we know the amplitude is 1/2, so it's going to go up to 1/2 and go down to minus 1/2. So now that we have everything labeled, we are ready to graph. Okay, so we're going to sketch the graph. The way you sketch the graph is you have to remember that sine starts at 0, 0, and then normal sine is going to go up. The way you actually draw the points in, I am going to require that you do draw the points in before you start sketching, is you have to go in this order. Sine goes up, down, down, up. So the quarters that we drew in, that's where we're going to put these points. So we're going to start at 0, 0, and then it tells us we're going to go up, down, down, up. So we're going to go up to the maximum where the amplitude is on that quarter point, down, okay, and then down again to the minimum, and then up, back to 0. And then what we do is we connect the dots in a smooth curve that tells us this is a sine graph. And we can do the same thing on the left. If we wanted to graph some more, you would start on the left and you draw one period again. So one period is pi, so then if you go to the left, that would be minus pi. Half of that is minus pi over 2. Half of that, minus pi over 4, and then minus 3 pi over 4. Okay, and then we're going to kind of just draw the same thing on the left. Remember that it's going to connect, so we cannot go up, down, down, up. It has to do the opposite so that it connects. Okay? All right, so let's do another one together, and then you're going to try the last one. Okay, so look at this. The first thing you're going to want to do is write A, B, period. That's the basics. A is 1.5, B is 2, so the period is 2 pi over B, or 2 pi over 2. It turns out to be about the same thing as the last time. Okay, so pi. All right, we're going to draw our xy axis, and you may want to just put in your maximum minimum since those are easy. So 1.5 here and negative 1.5. And then you're going to draw your period. Period is pi, break into half, pi over 2, break into half again, pi over 4, and then 3 pi over 4. And then since there's no negative on it, we know this is a normal sign. So we're going to start at 0, 0. Goes up, down, down, up. Connected. All right, so let's go ahead and have you pause the video and then try the other two. You're just going to graph one period, so it should be really fast. And what you want to do is you need to label the axis, or else every sign graph looks exactly the same and there's no point in graphing them. C is a little different. Please be careful. There is a negative on it, so you have to flip the graph. So pause this video, try it, and then come back and check your answer. All right, so let's take a look. For B, A is 3. B is a little bit tricky. B is pi over 2. Now, you probably have never seen pi over 2 before, but that's okay. We can still graph it. Period is 2 pi over 2. Okay, that is a complex fraction. Make sure you recall how to simplify that. That's 2 pi times 2 over pi. So that is 4. We've never seen a period with 4, but that just means 4 radians, so it doesn't really matter. We can still graph it. Okay, so what you want to do is do the same thing as before. Label your amplitude, 3 and -3. Draw your period. Period is 4, and that's okay. It's just 4. Half of that is 2. Half of that is 1 and 3. And we are drawing this like a normal sine graph. So it starts at 0, goes up, down, down, up. And that is 1 period. Okay, last one. Whoops, another color. A is absolute value -3, so that is 3. Please don't put -3. B is 1/2, and then period is 2 pi over B. B is 1/2. Again, this is another complex fraction. 2 pi times 2 over 1, or just 2. So this is 4 pi. All right, let's draw this. Okay, draw our amplitudes. So it's going to be 3 and -3. The period is 4 pi. So we're going to divide that into into half. So that's 2 pi. Half again, pi, and then half again, 3 pi. All right, let's draw a sine. This one's a little bit tricky because there is a negative in the front, so that means we start at the origin, but this time we're going to go down first, and then up, and then up, and then down. So it's going to just reflect over the x-axis.